Welcome to this webinar about features and benefits of Duplex Tigral in high-performance pressure die casting. Today's topic is the unique properties of eifeler's Duplex Tigral PVD coating and the benefits it can provide to your high-pressure die casting process. My name is Amber Gonzalez, and I am Digital Marketing Coordinator for Festalpina High Performance Metals in North America and moderator for this webinar. Before we start, let's make sure you can hear us and know how to ask questions. There will be time for questions and answers after the presentation. You should see this console on the right side of your screen. So please type in your first name and location so we know that you can hear us. Let's do a type of sound check. Okay. So Illinois, good. So sound is right. So welcome everyone. This webinar will be recorded. To receive a copy of the presentation and the recording, we ask you to contact us after the event. And first, a disclaimer. Please note that this presentation is for informational purposes and unauthorized reproduction or sharing is not allowed. Let's start with a short introduction about today's presenter, Jerry Barvenek. For over 30 years, Jerry has devoted his career to offering value-added solutions to automotive manufacturing. From unique chemical solutions to innovative PVD coatings, he has offered alternative options that have improved manufacturing efficiencies and increased part quality while reducing overall operational costs. He currently directs the Canadian eifeler coatings and thermotech operations in Canada and is always available to discuss unique challenges and possible solutions. Hi, Jerry. Thank you for joining us. How are you today?
Good morning, Amber. I'm very well. How are you? How are you down in Mexico today?
Good, thank you. It's a very sunny day, so it's
I wish.
happening.
I wish. Here it's damp and rainy and cold. So you're lucky to be there.
It's still good, but great. So let's get moving. I'm sure everyone wants to learn more about the new trends and die materials in high pressure die casting. So over to you, Jerry.
Okay, thank you very much, Amber. Good morning, everyone. Thank you for joining us this morning on the advantages, features, and benefits, basically, of PVD coating. And I will specifically focus at the end of this presentation towards our proprietary product, Duplex Tigral, that was developed as a solution for HPDC. So as you all know, there's a lot of demands in HPDC, and they're increasing constantly. You have part size and geometry is getting more complex, and to suit that, you have higher pressures, increased velocities. You're challenged with shortening your cycle times. And while this is all going on, you have much more aggressive aggressive alloys that chemically attack your steel. And then to make it worse, you have cost restrictions that we all experience that make controlling this difficult. Now, the lines on the side here, they just imply that none of these or all of these issues can come up at the same time or in various groups of. So you're not restricted just to one issue at a time, and it makes it much more complex. Now, some of the demands that these challenges present, or issues, you have heat checking, gross cracking, you experience erosion and washout, soldering and corrosion is common, and plastic deformation we've all experienced and seen. So PVD coatings can't assist at retarding or preventing all of these, particularly the plastic deformation and gross cracking, but they are a good solution to many of the items. Now, some of the available solutions that you do see out there, you will probably, hopefully, you'll see Richard Oliver's presentation from Udahome. So you have steel selection as an option, and you can optimize your physical and chemical property via this selection, via which steel you opt for. You have technology and engineering, and that can be additive manufacturing, for instance, where you 3D print conformal cooling, sub-inserts, and so forth. You have heat treatment. Now, that's a soft spot for me, and I'll get into that because I do oversee the heat treat operations here. But basically, you can improve physical and chemical properties of your material by properly heat treating the tools. PVD coatings, I'll get into that, but bottom line, they're barrier guard on the surface, and process enhancements, and that's up to you. Personally up to you to put in the proper engineering protocols to run your equipment properly. So it's basically a best practice type scenario to ensure that everything's running as it should. Okay, so I'm going to take a few minutes to go over some heat treat points because heat treat, in my opinion, is probably one of the most important aspects of any tool build. Bottom line, why do we heat treat? It's to optimize physical and chemical properties of the alloys. So what we're trying to do is obtain the properties from the alloy as it was designed to operate. So you're ensuring that your austenite conversion is optimized and your microstructure of the material is as it should be. Correct hardness is important, and you proper heat treat will give you the range of hardness that you require. But please, don't kid yourself. Just because a material has the proper Rockwell, say for D2 might be 46 to 48, doesn't mean it's heat treated properly. With correct hardness and proper toughness on the next line, you really do need to ensure that you get the right number of tempers, the tempers are in the right temperature range, and so forth, because there's more than one way to get hardness, so-called correct hardness. So please make sure that no matter what heat treater you decide to use, make sure that they follow the procedure as outlined in the Udahome or Bowler or no matter what manual, as outlined, that they follow that procedure. And one thing that also, by following proper procedures, you can get corrosion resistance. And corrosion resistance is not as important in die casting, but there are situations that it really does come through critical. Now, one thing that heat treaters can do is relieve residual stresses in your block. And that's important because based on current geometries, complex geometries or size of blocks, the last thing you want is residual stresses in the material that can result in cracking and distortion and so forth. Now, there's two types of stresses or stress relieving that we can consider. And we get a little more specific than some heat treaters, and I know this is other heat treaters do use this nomenclature, but we have stress relieving and stress temper. So these are both processes that reduce your or de-stresses in your tooling. Stress relieving is in the annealed state, and it's at a higher temperature. Higher is relative, but it's at a higher temperature than stress temper, and it's basically used to relieve stresses in the material. For instance, on large blocks before heat treatment or hardening processing. Okay, because you do get stresses in the material from machining, perhaps welding. and that can impact how the blocks perform in the quench process. If there's a lot of stress, they can crack. So for larger blocks where there's a lot of investment, where there's a lot of size differential within the block, cross-sectional differential, I highly recommend you do a stress relief before hardening. Typically here we do anything over 1,000 pounds. We start to consider stress relief. Stress temper is done at 50 degrees below the highest tempering temperature. Okay, and that is typically done on the hardened, or always done on the hardened and tempered material. And it would be considered when, again, you do some welding, some engineering changes, and so forth, and the material does incur stress. So it's really critical. Remove the stresses, and that will reduce cracking in your blocks. Now, you know, the true value of heat treat. What really is the true value of heat treat? And I think this is one of my favorite slides here. You'll see the pie, and you'll see that manufacturing, you know, the cost of overhead, your facility, your equipment, your personnel, that probably eats up bulk of this, your tool build costs. You have PVD coating, and of course the steel. You know, that, and steel, depending on grade, that can vary. But ultimately, at the end of the day, the cost of heat treatment is the lowest proportion of the entire process. And it's also one of the processes that's overlooked the most. You know, it's considered, oh, it's the old school, you know, hardening, quenched in fire kind of thing, you know, and just get it over with, get it hardened, get it back. Please don't underestimate, no matter where you send your tools, don't underestimate the true value of heat treatment, because it doesn't matter how fancy your CNC machines are, how brightly lit and painted your facility is, and how highly trained your people are. And it doesn't even matter how exotic the material you use to make those tools. If you don't heat treat it properly, it can be scrapped. Everything goes to the garbage. So please do that. Follow best practice for best performance. Okay, I'll quit on that, and let's get into some PVD coating discussions. So who is eifeler and who is Vacotech? eifeler and Vacotech comes out of Germany. We have a 30-plus year history of creating proprietary technology. eifeler creates the technology, be it the coating, typically the coatings, and Vacotech division creates the equipment that applies the coating. So we have our own equipment and our own proprietary chemistry. It was acquired by voestalpine in 2013, and we have a global presence now. We make coatings specific for industry segments. Duplex Tigral, for instance, as I'll get into, was created specifically for aluminum applications and die casting, aluminum stamping, and so forth. So anytime a coating comes into contact with aluminum, Duplex Tigral is our go-to product. You know, back 7-8 years ago, there was one location in the USA, in Chicago, and that was under the eifeler name prior to acquisition. Canada was the first location globally that was commissioned under the voestalpine banner. And since then, we've expanded our U.S. presence to 6 facilities, 2 in Mexico, 6 in USA, 2 in Mexico, 1 in Canada. And you can see here, we do have constant expansion globally to basically supply the same technology, no matter where your affiliates, customers, or suppliers may be. So you can be rest assured that no matter where you need coating, We have the same equipment, as you can see in the background here in this picture. We have the same equipment and same processes, same chemistries available to you. Okay, so what are PVD coatings? Well, PVD, it stands for physical vapor deposition. And it's a coating technique which basically vaporizes solid metal, and it reacts to solid metal with a gas. And this occurs in a heated environment under vacuum. And the chemistry resulting from this reaction is the coating as it deposits on a part. Positive, negative kind of attraction in the chamber, and you get a very hard coating applied to your part, which is extremely thin. 2 to 10 microns is typical. In fact, 2 to 6 microns is typical. And to put that into perspective, one filament of hair on top of your head is between 80 and 100 microns. Okay, so we're talking pretty thin material here. Extremely high hardness. Upwards of 4,500 Vickers is typical. Duplex Tigral is lower. I'll get into that. We have a coefficient of friction that can be lower than polished steel itself. We have coatings with various thermal stabilities, and that can be upwards of 2,100 degrees Fahrenheit. Very important, as you would anticipate in a die-cast environment. Chemically inert, again, very important in die casting, considering the aggressive nature of some of these silicon alloys and so forth. But it's so inert, you may not realize, but PVD coatings are used for implants, dental and bone implants, surgical instruments and whatnot. It's considered totally biologically inert even. Now, one thing that's extremely important is adhesive strength. Coatings do not absorb into the surface. They basically stick to the surface of the tool. But the important aspect of this is that they don't delaminate. Okay, they have very high adhesive strength. Unlike maybe you've seen hard chrome. Hard chrome after a number of cycles will start to delaminate from the surface of whatever part you're using it on. This doesn't happen with PVD coatings, but it will eventually, like anything else. It is a sacrificial layer, and it will wear through it. So let's see, what's the next? Okay, we have an example of our chambers, our coating chambers. The one on the left here is our Alpha 400, and this is a 900. Basically, the numbers are designation based on the size of the chamber. So all our chambers are random arc PVD. And the random arc is basically a process where we apply an arc to, you'll see it here in the large chamber, these two round puck-like things. That's our cathodes, and we apply an arc to those cathodes under vacuum and temperature. These pure metal alloy targets or cathodes, they vaporize into a plasma field. And the dual targets, as you see here, dual evaporators, they allow us to create complex and interesting chemistries with different properties. We have a very high plasma density. The advantage of having a high plasma density is that we have a very tight, packed coating structure. It's very important that you have that, because we do deposit coating as a atom of material at a time. And if it gets out of control, the coatings can get rough. Picture a beach with fine sand and a beach with rocks. So we want that fine sand type structure that inhibits the molten aluminum and chemistries associated in it from penetrating through the coating and attacking this substrate. One thing that we're proud to say is that we were the first ones to introduce in situ plasma nitriding prior to the deposition of the coating. This improves coating support and also provides additional cleaning in the cycle to prevent any sort of delamination or adhesion issues during the cycle. And it's something that's important to all of you. You may be wondering, 2,000-pound weight capacity in this tool. And I think you saw in the previous slide that large cavity. We can do upwards of 37 inches tall and about 31 inches in diameter. Now you'll notice in the Alpha 900 diagram here, it's a round table. It's round, primarily we call it a planetary. It turns. One thing that you need to keep in mind in PVD technology, especially ARC technology, is that it is a line of sight process. What does line of sight mean? What it sees, it can coat. So if it's hidden from the view of the plasma field, and the plasma field does travel in a straight line, it will not get coated properly. Yes, there is a little bit of wraparound, but it will not apply a significant amount of coating to actually protect the tool. This also applies to holes. There's an aspect ratio of about 1 to 1.5 to 1. What that means is if your hole or your rib is, let's say, half an inch across, the plasma field will only penetrate half an inch to maybe 3/4 of an inch down into that rib, into that cavity. So if you have something that's a ribbed component that's 4 inches deep, it has the ribs are 4 inches deep and only a 1/4 inch or less, it will not get down to the bottom, okay? Keep that in mind. Oh, excuse me, I'm just going to have a little drink here. Keep that in mind, and if in doubt, please contact me or one of our representatives, and we'll review your print and tool. Okay, so now we get to the Duplex Tigral. Features of Duplex Tigral. It's a dense aluminum chromium composition, as I indicated, and that's important to make a stable coating that's chemically inert relative to your aluminum alloy. So when I say chemically inert, it doesn't react with your aluminum alloy. It's got a micro hardness of 3,300 Vickers. Put that into perspective, your steel surface, hardened steel surface, is probably less than 600 Vickers, so substantially harder. Thickness is only 5 microns, 5 or more, depending on the size of the part and configuration of it. Thermal threshold is 1650, which is well above your aluminum melt temperatures. And we have the in situ plasma nitride process that I indicated will help adhesion and support all of the actual coating film. But the benefits is what you're interested in. The benefits you'll see is increased tool life, lower tool maintenance, reduced downtime, which is absolutely critical in this age. And with reduced downtime, you do get higher productivity. And hopefully you should see improved part quality and reduced scrap, which is absolutely critical in any operation to keep your costs down. So let's see, how can PVD help? Okay, so here you have your typical failure modes that you're all familiar with, okay? And plastic deformation, a PVD coating will not help. Let's just put it this way. 5 microns of coating across a surface on a 800-pound block isn't going to cut it. You're not going to prevent plastic deformation from occurring if your two sides of the cavity smash into each other or something else. Okay. All right, we have heat checking. I put this as an orange. So coating directly cannot prevent heat checking, but I'll explain what the coating process or how a coating process can influence heat checking. We have our erosion washout and soldering. Absolutely. Duplex Tigral will help with that as a barrier coating. I'll get into those with more details. And oops, going the wrong way. And then we have gross cracking. And I put that in orange because PVD coating is not going to prevent gross cracking. But I go back to heat treat. Do it right. Do it right the first time, please. Okay, soldering. What's soldering? You know, bottom line, it's a chemical reaction. You know, it's chemical bonding of the aluminum with the iron in the steel, and basically the aluminum wants to react with the iron, and the aluminum starts to basically build up. That this reaction, the reactant, starts to build up on your tool, and as you know, causes rejects during part ejection, and can create tool breakage as well. Because, for instance, I've seen an application where the core pins were soldered to the point that the part wouldn't eject, and due to ejection pressures and so forth, the core pins would snap. So Duplex Tigral creates an inert barrier that prevents this chemical reaction, prevents the buildup and the constant attack of the aluminum on the steel. We've seen great results. The one core pin example that I shared just a second ago, there was literally a $1 million savings per year in maintenance, downtime, and replacement costs. Phenomenal. And that's just with applying, you know, 5, 6 microns of coating to a core pin. How can you turn that down? Erosion and washout, and this is just basically abrasive, erosive attack from your aluminum on the surface of your tooling, and you probably have seen this compounded exponentially at gates and so forth. And again, with the Duplex Tigral at being 3,300 Vickers, and your steel being at 600, you know what, 6-7 times harder than your standard H13. This hardness greatly delays the erosive attack. So if you have parts at gates or with fine details, as perhaps a gasket groove insert, it will greatly retard the erosive effect of your alloy. Will it prevent it perpetually and forever and ever? No, there's no such thing. But if I could suggest, if I could offer, or if coating can offer, say your baseline is 5,000 parts, but all of a sudden you can increase to 60,000 parts, there's something to consider. Here we have water jackets that we were very successful at preventing some erosive action. You can't really see the area, but it's in the back here, and the erosive action would ultimately lead to a breakage of like an ear that sticks out off that, a detail. Heat checking, as I said, coating itself will probably not prevent heat checking, no matter what anyone tells you. Okay, that's a function of the material being thermally cycled over and over throughout the day, sometimes thousands of times a day. But what we do is the surface preparation. Now, common practice has been in the past to draw polish the surface, and there's a lot of reasons. There's a lot of theories for doing that, but we've proven that a draw polish is not required. Okay, and in fact, it can be detrimental. In particular, draw polish is detrimental to coating, to applying coating. I don't recommend you apply coating to a draw polish surface. Picture peaks and valleys, very sharp peaks, and coating being at 5 micron, it will not fill in the peaks and valleys of the surface. So what happens? You're coating a peak, a very, very minute, very sharp little peak. After a few hundred shots of a high velocity abrasive alloy, those peaks do bend and they break off, and that exposes coating underneath it. And it exposes steel underneath the coating. When you expose the steel, you allow the attack of the alloy, the abrasive and the corrosive action of the alloy on that steel, and then you get, as people say, coating failure. But it's not coating failure. It is a coating failure as a result of poor finish. So what do? We highly suggest, we have one of two recommended surface type applications. One is a high polish. And I'm literally talking about a mirror polish, as you would see in a mold. We've seen many applications that have been very effective with that, and they can prevent heat checking, because those peaks and valleys, they are potentially propagation sites, okay, for heat checking. So you remove those propagation sites, you apply the coating on top, and you'll get good performance. On the other side, your other option is go away from the high polish and do what we call microblast. But you still have to stone it so it's smooth, and we suggest 400 or 500 grit stoning. Remove the machining marks and everything, and then blast it with a media, with a very soft media to give it a nice smooth texture. The difference between the two is the part finish. In one case, you'll have, in the high polish case, you'll have kind of a mottled, shiny, kind of irregular surface for what it's worth. And on the microblast surface, I really like, because the parts come out very uniform. Why do we have two finishes? Well, I think there's a factor of cost there. That the high polish is important, but the high polish does add additional release advantages in difficult to eject parts. Now, coatings will not prevent heat checking at all, and it doesn't matter, or should I say coatings. Surface finish will not prevent heat checkings caused by inferior grades of steel or inferior heat treat. So please, again, keep that in mind. Best practice first time. Possible applications, main cavities, both sides. Keep in mind, deep ribs are difficult to coat, but if they're away from the gates and so forth, we have many customers that believe in coating on those tools anyways, because it does protect long life. Sprues and core pins, sprues. A lot of sprues have IDs running through them from top to bottom, and some of them can be 10, 12 inches long. Again, keep in mind that PVD coating will not penetrate all the way through. If it's a 1-inch hole down the middle, it's only going to go about a 1 inch from each end. Floating inserts, sub-inserts, shot blocks, chiller blocks, interestingly enough, have caught on, and they're kind of furthest from the flow as you can get. But we have many customers that are coating chiller blocks, and I'm still not fully understanding the advantage there, but they are adamant on it. And now with the advent of 3D printed tools, we have shown successfully that PVD applied to 3D tools successfully and provide additional improvements. Now, 3D being so much more expensive than regular tooling or conventional tooling, there's even a higher priority or consideration for the use of coatings on 3D on 3D tools to protect your investment and get the most out of it. So in the end, there's lots of applications that we can consider. Bottom line, though, and I'm not going to attest that PVD coatings are an elixir and will improve performance in every tool that you see or that you may have. There's many tools that coating is just not required. So please select the tools as accordingly, and I'm sure you know the ones you have problems with. Pick those tools. Give me a call or one of our account managers, and we can go over your design and whatnot and basically recommend whether or suggest whether or not PVD coating will work or not. We're here to find a solution for you and maintain a long working relationship with you. So on that note, questions and answers I'd more than welcome, and I'll turn it back over to Ambar. So thank you very much for your time here.
Thank you, Jerry. For all attendees, if you have to leave, please know that we have recorded this webinar. To watch the recording and have a copy of the presentation, please contact Voestalpine Coatings Canada or your local eifeler sales representative. We will now take questions, and we will keep this meeting open until all questions have been answered. So please write down your questions so we can start. We have one. So what surface preparation are required for coating?
Yeah, okay, and as I indicated earlier, stay away from the drop polish. And if you can use the diamond polish, you can do the microblast. But if you want to stay away from those, just provide the smoothest finish on the surface possible. Bottom line is that coatings will not fill in machining marks because you're only talking 4 or 5 microns, and machining marks can be probably measured in thousands or tenths or whatnot. So, provide the smoothest possible surface to your coater that you can possibly do in-house, and then consider coatings like gasket groove inserts, very fine details. Give it a high polish in those areas, coat those areas, and then that will prevent the details from breaking out. Hope that helps.
Okay. Can the coating be removed for engineering changes?
Yeah, good question. Absolutely. We have 2 ways of stripping the coating. The first way is chemically, and we've done that a number of times when at the last minute, we've coated a tool, it's returned, and there's substantial engineering has to be done to it. So it doesn't change the surface at all. If it's highly polished, it'll haze it up a little bit, but with a quick polish, that'll bring it up, and then we can recoat it. Now, if you have a spot engineering change, blasting with an abrasive media at say 80, 90 psi, coating can be removed that way. It takes a little bit of time, but it will come off. You can make your machining changes or whatever you need to do, and then we can, with polishing that area, we can recoat the whole block. We can't just coat that area. Now, best practice is to strip the coating off completely. But in a pinch, and as a cost savings measure, we have coated the entire tool again and put coating over coating and whatnot. Is it best practice? No. Is it effective? Absolutely is. So those are your 2 options. Oh, and I should mention, a well-used tool, something that's, say, a couple 100,000 shots. I don't recommend the coating is stripped. and recoated with a polish. Our findings with our partners out there is when you coat a well-used, experienced tool, you do not nearly get the tool life as when you coat the brand new tool. So keep that in mind. Okay, thank you.
Okay, and what is the typical shot count for a coated tool?
That's loaded. That's a loaded question, and there's no such thing as typical shot counts. And as you can imagine, every part's different with the different alloys that are available, with the different geometries, different tooling, different practices in the various shops, and different operators. I can't really guarantee you that there's a typical shot count. We have examples where we've gone from 5 to 50,000, and we've had examples of going from 10 to 120,000. So it's up to you as much as it is up to the coating to ensure that best practices, do it right the first time or just do it right, are followed, and also best practices are followed in maintaining the tools. There's always those guys out there that will take a do more and start grinding at the block to remove a little bit of pickup in an area. Please get those do mores away from your tool guys, and use light stones or sandpaper or something like that to do light maintenance on the coating. The coating will hold up to light stoning and whatnot, but it certainly won't hold up to a grinder. Okay, so I hope that explains it. I hope that answers your question. Thank you.
Okay, so if there are no more questions, thank you, Jerry, and thank you all for attending this webinar. If you wish to reach Jerry or an eifeler representative, please visit our website, www.eifeler.com/nam, or call us in the United States on 630-587-1220, Canada on 800-665-8335, and Mexico on 52442-689-5900. There will be a short questionnaire when we close and also in the follow-up email. There you can also let us know if you want to be contacted to discuss further. I remind you that this webinar was recorded and we will make it available on demand. We wish you all a good rest of the day, and thank you very much, and goodbye.
Thanks, everyone.